1. All right, y'all. Let's look at this beast. So we talked about this on Friday, correct?
Yes.
We talked about just between relative or local, and then absolute global. Be careful, these terms, I think I said in the video too, are interchangeable. Relative and local are interchangeable terms. Absolute and global are interchangeable terms. The difference is relative is any bump or dip. Absolute is the smallest or the absolute largest, right? So let's go and look at these functions and identify some stuff about them. This is also a good way for them to realize how ignorant I am to everything and incompetent. All the I words. All right. Let's look at this beast. Label and identify relative and global extreme. Will this one have an absolute or global max min? No, because it goes to infinity and it goes to negative infinity. So there's not one value I can say this is the smallest it'll be and this is the biggest. So it won't have any abs, like me. But, oh no, don't lag on me today. Oh, gee golly. No. I did put new batteries in it. There's none, right? There's no absolute max, no absolute min. But do I have relatives? I got lots of them. Do I have a relative max? Oh my gosh. Nope, I'm writing it all. Do I have a relative max? Yes. What is my relative max? 5. And it's right here. Now, if I changed that question, what I just asked to, where is my relative max? What would you have said? 1. 1 is the where. What is the value, right? So my relative max is 5. It occurs at 1. So now, do I have a min, a rel min? Oh my gosh. Why today? I think my filming is slowing down my pen writing, and I don't know why. So what's my relative min? 1. Where does it occur? 3. All right. I'm going to try something here. All right, let's take a look at B. Now here, do I have any absolutes?
Yes.
Are you sure?
Yeah.
Absolutely I am. Do I have an absolute min?
Yeah.
No, because it goes down to negative infinity. Do I have an absolute max?
Yes.
Yes. So I have an ab max. Wow. Do you guys see this? Look at the lag today. Oh my gosh, I can't do it. What is my absolute max? 8. And where does it occur? 2. All right, let's look at, do I have a relative max? I don't have anyone in my family named Max.
I do.
Oh, then that person has a relative max, not naming names. I should make up fake names for everyone. Eagle 1 does. All right, where's a relative max? 0, right? Where does it occur? Negative 3. Let's change color one more time for fun. Do I have a relative min? Yeah. Where's that occur? Or, ooh, what is it? Negative 2. And where does it occur? Negative 1. Are you guys getting the picture of the difference between where and what, right? Where is always X, what is Y. I'm actually going to do this a little bit differently. Oh, but I want on the lecture. Whatever. You guys try C and D. Try C and D with your table partners. I'm going to pause it.
Why is the relative?
1. All right, there you go for the people in the video world. You can check yourself. And if you have any questions, feel free to bring them in. All right. All right, let's go back to learn something new. The next thing we're going to talk about is the difference between even and odd degree polynomial functions. Now, the question was asked a few times about how do you know max, if it's an absolute or non-absolute. Well, what's nice is if it's an even degree, it'll have an absolute max or an absolute min, where odd degrees will not. Because if you recall, even degrees are either going to look like a U or an N, right, with wiggles in between. So they'll have an absolute max or min, where odds do something and then they go up. So they will not have absolute maxes or mins. Okay? So if you have your graphing,
It's even and odd.
x squared is an even degree, x to the third is an odd degree. X to the fifth is odd. Whatever your biggest power is determines the degree.
If I have a -6 and a -5,
Like x to the -6,
yeah.
that's an even. If that's your biggest power, the biggest power. Like look at. Well, here. Let me just show you in here. Look at this beast, right? We have x to the fourth minus 3x to the third plus 4x, right? What's my largest power? So it makes it even. And that's also why it opens up, right? So will this one have an absolute max or min? Yes, because it's even. And if you guys don't mind because we spent a lot of time on it, I'm just going to give you the answers and pretend like you had your calculator. What you would graph it, right? If you want to try one of them to make sure you're doing it right, by all means, go for it. But we have our 3 points, right? It actually helps. So the big thing is on these, which one of these 3 points would be an absolute max? An absolute max. Are any of these 3 absolute max? Why don't I have an absolute max? It goes to infinity. So no absolute max. Are any of these 3 points an absolute min? This left one is, right? Because does the graph go below that? No. So that's just absolutely the smallest we can get, right? Then what would this point be? Relative max. And that'd be a relative min.
Not as good as absolute.
All right, I'll give you the points in a second. I'm just going to pull up the other document that's already done. Let's look at this piece right here. What's my largest power? X squared, right? So I know that I'll have is that an even or odd? Even. Do I have, how many maxes or mins do I have? Just one. And what is it? It's an absolute. So how would I find that on my calculator if I don't have the chart? Yep, or I just click to the other sheet that has the answers on it. This teacher who made this is going to find me and be like, this is inappropriate. Oh, they don't, okay. Oh no, they're down here. So we were right with those. And then these would be your mins and your max. See, they went through and they just labeled them. I don't know, any wild questions on that one, or you feel okay? How am I going to do this?
Actually, that's kind of, no, it's still high.
It's better.
It's better.
Yeah. All right. Any questions on those two, or you guys feel okay? Before I scroll to the next one, since you guys have your packet, The next one, what's your power? 3. So that's odd, right? If it's odd, do I have absolute maxes or mins? No. So same if you look at the next one. It's negative 0.5 x to the third. What's your biggest power? 3. Do I have any absolutes? Absolutely not. Does that help clear out the even odds? We'll actually be proving this. Oh, now it's going to be like that the whole time. Whatever. Ooh. Origin symmetry. Do you guys know what that means? It means if I take this graph and I rotate it 180 degrees with the origin being the center, it's the same graph. You guys, you might have saw that in Algebra 2. Ay. Alright. Was anyone having calculator problems with these max mins? If you are, make sure you get that. So am I, but that's okay. We still get our job done. But make sure we're getting that. If not, we gotta get it fixed, right? That's gonna be a big deal for this unit. False.
What if I get another microphone so I bring it?
No. Chimney crickets, guys. This is for my monetary. That's how I'm gonna make my money.
Yeah, once you retire,
No.
drop the dollar.
All right. So why are we doing all this? What's the goal? No,
Yes.
we need to look at concavity. That's going to be a big deal. We introed this in 1-1, right? So in 1-1, we looked at concavity up, concavity down, points of inflection, correct? We're going to do it one more time. So what part of this function is concave up?
From -2 to 3.
Remember, concave up means we look like what? A U. So where does it start looking like a U? Am I still a U? Am I still a U? Uh-oh, what happens around here? You look like an upside down U, right? So, what color do I do for the upside down U? It says blue. That's blue enough. So again, I'm going up, I'm going down. And then what do I call that point where it switches? Point of inflection. All right, does that look like a pretty decent graph? So what do we call it when it looks like a U? Concave up. What do we call it when points down? And what do we call that point again? You guys got it. It's too easy. No. POI, point of inflection. Get used to it. Now for the new thing. How do I find a point of inflection on this graph given I don't know it? How do I find it? What do you... 1 second. I need people to focus. This is something new. How do I find a point of inflection? What do you notice about that point? Where does it fall in between those two usually? In the middle. So that midpoint formula that we learned so long ago, it comes back. Do you guys remember it? It comes up in Algebra 2 geometry and Algebra 1 and in 8th grade math. So you add up your x's and you divide by 2. You just find the average of your x average for your y. Any questions where I got these values from? You add up your x's divided by 2, add up your y's divided by 2. Average of x, your average of y. So according to my calculations, this becomes 1/2 -1, right?
Yeah.
Does that look about where we put that red dot? Yeah, it's pretty good. I'd say we got it. I'd say we're good to go. All right. Any questions on this concavity and points of inflection? Going once? Going twice? Sold to the honor the courageous. All right, let's see if we can do this now. We don't even need math. How many points of inflection occur on the graph shown below? Let's label each one and shade concave up and down. I'm actually going to do B first. Is that okay? So let's do green again for concave up, because why not? What do we got to lose? So where do I look like a U? Does this look like a U? When do I stop? Tell me when to stop. Okay. That's not U. When do I start again? Here? So I'm going to underline this so I know green is concave up. Sound good? You want to use blue again? This purple that's disguised as a blue. Where am I concave down then? Yeah. And how many times do I change? Twice. So how many points of inflection would there be? There you go. We'll make them red. Any questions on that one? So how many times do we turn? 3. And every turn is a relative min or max, right? Relative min. Well, absolute min, relative max, relative min. So if I have so think about this. If I had 4 turns, how many points of inflection am I going to have? 3. If I have 100 turns, how many points of inflection? 99. Does that make sense? If you have 1 turn, how many points of inflection? 0, because that's just going to be a straight parabola, right? Straight U or N. Okay. Anything too bad so far? We're just putting everything together. Let's put it all together. Let's figure this out. Figure it out. That's why we say. Last example of the day. Well, it's a lot of parts. Look at us. So, we can have 3 places a point inflection can occur. It can occur at 0 with a multiplicity of 3. That's what that one looks like. You guys remember what multiplicity means? Yes. So like, if I had the function x minus 2 to the third equals 0, how many times is 2 a solution of that? 3 times, so it has a multiplicity of 3. You guys would have saw that a little bit in algebra 2. You can also estimate between 2 consecutive extreme values. That's what we've been doing, right? We look at the relative max and min, and we kind of guesstimate where it changes. Or you can estimate a possible between a 0 multiplicity of 3 and the closest relative extreme value.
Let's just guess.
Estimating. That's the science term for guessing. If you want to say guesstimate, that's fine. Let's put it into action. Let's look at A. Look at the graph. Find the points of inflection by 1 of 3. Do they even give us the function? They don't. That's cool. So I'll help you because this is going to be new to you. I don't care if you memorize which rules to use, but we got to be able to find them. So would you agree that this is concave up right now? Until about where?
Like 1.
You guys think it? Sure. You know what? Whatever. All right, so we say that's, what rule did I just use there?
Yeah.
Do I know the extreme values? So before we took the average between two extreme values, right? Do I know what they are? No. What did I do?
You just estimate
I just estimate. Which rule lets me do that?
3.
Rule 3. So rule 3, let us get the point 1, negative 1.5, correct? Oh my gosh, it's writing well now. Is this on? It figured it out. All right, so we good on that one? Okay. Now what's another one here? Now this one's weird. You see how this is concave down and that switches pretty quick. That is a special one. That is a rule 1. That's what it looks like. Anything with a multiplicity of 3. Oop. Yep, that's how I'm going to write it. That's a fancy. It's a rule 2 to the first power. All right. Is that 3, 0? How do you think? You have to watch it too, in person. We get the experience. All right. The way you can remember this one is this is what x to the third looks like, right? And x to the third has a point of inflection at 0, 0, right? That's because it has a multiplicity of 3 there. Okay? So we good on A? Okay. Let's do another one. Let's show another way we can do a point of inflection. On B, now on this one, could we estimate it? Yeah, but it's kind of messy in there, isn't it? Do I have a pretty good min and max I can use? Yeah. What's the 1 point? Negative 2, 5, right? That's my relative max. And I have a relative min of 3, negative 2.5, right? So now what can I do between those 2 points to find my point of inflection? Midpoint. Find the mid, add them up, divide by 2, right? Nope. Nope. It's commutative. So negative 2 plus 3 over 2. Honestly, the hardest part for you guys is going to be figure out which method to use. If you know the points on the graph, this is probably one of the best ways. Any questions on this? What I've done so far? I got 0.5. $1.25. Now, if you're using a calculator, could you always do it this way to be a little bit more accurate? Yeah. Oh, Jimmy Crickets. To find a point of inflection? I don't think so. Does that look about right? 0.5, 1.25 would be about right. Oh, wait, hold on. Hold on, I can math. We'll be about there. Does that look good? Yeah, that looks great. Yep, that was rule 2. You guys try C. Try C. There's 2 of them. And I'll tell you a hint. Use rule 2. Use rule 2. Try C. And that's actually, yes, for both of them. You can use rule C. And that's actually where I'm going to end this video. Nice seeing you, Internet.